Hey guys, in this video I want to talk to you a little bit about two things. The first is the impact of urban planning on two dimensions, the cost dimension and the carbon dimension. And the second thing I want to talk to you about is how similar Giraffe is to a spreadsheet. So I have a spreadsheet here, and this spreadsheet I'm using to explore building form on those two dimensions I said, cost and carbon. So I've got two sources of data here. One is the cost one, and this is the RLB Intelligence price estimator for Sydney. And what it's saying is if you're over 20 and you're up to 40 stories, the cost per square meter is 5,500. Now I assume that's per GBA and not per GFA or NSA. And if you're below 10 stories, but you do have a lift, it's 3,900. And so I presume if you're below 6 stories, like you're a true mid-rise and you have no lift, you're even more efficient than that. Or more cheap than that, more affordable. And so I've plugged those in. I've got the mid-rise at 3,950. I've got the high-rise at 5,500. And then I got this, now I didn't copy the source, but I'll post the link to it in this video, from Seascale. They did a study, I think for Toronto, showing the carbon intensity in kilograms per carbon dioxide emissions per square meter of GFA. Now this is a 1, 2, 3, 4, 5, 6 level building with a lift, looks like, and a basement. It's 276 kilograms per meter. And these high-rise, sort of 20-story odd buildings, maybe a few more, are between 326 and 535 kilograms of carbon per square meter of GFA. So what I've done is I've sort of done 276 over here, and then I've taken the midpoint towards the 326 of 400 kilograms. And I'm not quite sure what's driving it. It looks like these big podiums, etc. And this looks like retail underneath. Okay. And so this is how you do it on a spreadsheet, right? So you don't actually need Giraffe. You can say, all right, let's do 619 houses and set the average size to 90 meters. And then the cost per GBA is 3,950. Now, so what I've done then in the high cost equation is I've taken the number of homes, multiplied by the size of the home or the apartment. I've divided it by 0.8. So I'm factoring it up sort of the 20 odd percent. So there's excess building that you pay for, but are not in the 90 square meter apartments. And that's the total cost. So $275 million for 619 houses, or $383 million for 619 houses if they're high rise because of that additional cost. Now, I've assumed the same efficiency there, which I actually don't think is true. And this is kind of the Excel way of doing this. It's going to go inside one column left. We're going to say efficiency and actually parameterize this. And let's say it's 0.8 over here. It's not a dollar. It's not a dollar. It's a number. Oh no, it's a percentage. It's a percent. 80%. And over here, let's say the efficiency is 75% because there's so much more plant and core and rises, etc. And so then we do this instead of doing like hard coding it in the equation. We chuck it over there, and this is also percent, and it should say 75%. All right, and we just drag that equation down, boink, and that pops up. So that increases, right? So that goes to 408 because there's less efficiency that you pay for. And the carbon per GFA, we're just assuming this is GFA, and I could get into NSA, like the sellable but you can see it's pretty tricky, and it doesn't give you that much of a picture of what's going on. I think it's very useful to say, okay, well look, there's $133 million per 600 homes additional cost, and if you sort of normalize that, you divide the difference there by the number of homes, it's an additional sort of $215,000 per home, per unit. Under these assumptions, and I could be wrong here, this could be a GFA figure, in which case the efficiency's got to change, or it could be 100, you know what I mean? It's per GFA, and so then there's only $140,000 difference per unit. So let's assume the worst, but it's in order of magnitude. There's 70 grand in it. There's not, so 200 to 130. And then same with the carbon. There's about, if you do the same methodology, there's about 11 tons, and I'm dividing through by 1,000 over here to get from kilograms to tons. There's about 11 tons of additional emission per dwelling, per 90 square meter dwelling, because I'm assuming here that this is the GFA that I'm factoring up for the cost. All right, so interesting is these things are bigger, more expensive, more carbon intensive geometries than these things. But obviously you'd need a lot more of these things. To make one of those, you need a ton of them. So you need a bit more ground, a bit more land. You need to acquire it. You need to consult with a lot more neighbors, that's for sure. These guys, this guy and this guy has about the same amount of neighbors. Although, that being said, this one can be seen from further. So, people that are 2 streets over still care about this, whereas people 2 streets over from this don't. So, not necessarily true. But you can see how I'm kind of quickly running into a little problem, which is I'm trying to communicate something to you in Excel, and it's not working. And if you've worked in development, you'll know very frequently if you go in a development shop, there's little diagrams like this, which are very cool. They're useful diagrams, but they are not that cool, and they're not that useful. And what I'm drawing here is this. And so that's basically where Giraffe comes in, is you take this Excel, this little bit of analysis, this ready reckoner, and this is stuff the computer's so good at. There is the human brain, outside of a few very extremely talented individuals, is just not good at this. Like if I say to you, what if you add an extra 14 homes? What's the cost? You'd go like, oh, hang on, right? But 619, even 619 plus 14 is hard enough. I think it's 635, right? So you just type it in and all these numbers update. That's computers are incredible like that. They're very terrible at doing other things, but this thing they are very good at. So we always want to get the numbers done in the computer. And so what I've done is I've set it up in the computer, and I've done these 2 options. And so here's a low rise option in Giraffe. And then I've set up an Excel sheet, and you can see here like the total cost is just the gross area times the total cost. And what's the total cost? If we go down to the high rise, it's 5.5, 5.5, 5.5. And if I'm in the mid rise, it's 3.950 in the same way, and the equation is just the same. So the numbers are the same, right? So if I click on the total cost, it's 274.9, and over here it's 275.068. And this is because in Giraffe there's some rounding errors because, or rounding, they're not errors, they're just roundings, because we're going from a geometry here and then solving number of units. But 382, and if I change this efficiency to be constant, 383, right? So 382.5, so very, very close, because it is geometrical. But what you're looking at is some geometry on the page driving the spreadsheets. Let me just hide that guy. All right. And what's nice about having the geometry on the page is we can look at these things. And so for these, so for I guess an arrangement, an urban form that looked like this, we would be paying, we would be paying on the order of $274 million for the built form. Like, this is excluding the little parks, etc., that you're seeing here. And you're emitting sort of 25 tons of carbon per dwelling, which is 11 tons of carbon per dwelling less than this. It seems quite a high amount. Or the difference is this total tons of carbon. Okay. So yeah, so let's just double check that. So let's whoopsie. Tons CO2 per dwelling. And that's going to be the total amount of thingy divided by the total amount of dwellings. And we're going to divide that through by 1,000, So it's in tons. All right, and then if we round it, twink, twink, 25, 25. So we are right, 25 tons per dwelling versus 36 tons per dwelling. Makes total sense. Makes total sense, yeah, because every 4 square meters is 276 kilograms. So 4 square meters is a ton, a bit more than a ton. And there's sort of 25 fours roughly in 90. So it's a lot. So a built form like this, 25 tons, 619 dwellings, and $444,000 per dwelling without costing up the infrastructure, etc. Built form like this is 36 tons per dwelling and $618,000 per dwelling, but you get a lot more. You get a lot more park. Now, something that I was mentioning before was the impact on the neighbors, and this is where Giraffe is also extremely useful, because we can say, okay, what is the impact on the neighbors? Like, let's mark this spot here as a concerned neighbor. Pop an icon. Sorry, on the high-rise option. Actually, I'll put this on default. I'll unlock that, and so we can see them on both. And I'll put that icon over there. So this guy's getting shadowed by this option, sort of kind of starting at just before 3. So maybe that's quite late. So let's check this guy. So he's getting shadowed, or she's getting shadowed from about 2 right onwards in winter, under the high-rise option, under this high-rise option. And of course we could move the shadow for them, for this person, but it just moves it to someone else. So someone's going to get shadowed because height casts shadows. That's what it does, sort of geometrically. But under the low-rise option, this person is not shadowed. It would be worth noting that this person is shadowed, and potentially under the high-rise option, they're not shadowed. So no, they're not. So there's winners and losers. Generally, the shadow is more on the low-rise option, although the amount of consolidated open space in the high-rise option is much bigger, because we've densified the design. You know, we've piled up the dwellings on top of each other, and so that for a given number of dwellings, that gives a lot more open space. You can see these are small, like pocket parks, and the experience of this is like this, whereas these are larger parks, but the experience is more like this. And so what I want you to take away from this is just the sums, the maths that I've done here. It's very interesting in terms of the impact, the cost and carbon impact of different built form. Like, we don't need to know anything more other than this. And B, I want you to believe or see how similar a spreadsheet is to Giraffe. That they're basically the same thing, but that the color and power that having the geometries instead of just area inputs like this gives you, even if you're an analyst doing business casing, whatever kind of scenario testing you're doing, just how powerful it is. And hopefully how simple it is as well. Like, there's nothing, like, if you can do this, you can do Giraffe. I think the challenge is people often don't want to draw the rectangles, but how quickly you can get something very presentable and powerful to drive through a decision, make an argument, a very rational numbers-based argument as to why one outcome is superior to another on a given dimension.